Hola! My name is Zach Gillan, and today's video topic will be specific heat.
Specifically me, 'cause I'm hot!
Also known as C, as used in the equations that we've been using. Specific heat is given in the terms of joules degrees Celsius per kilogram, and is found by the equation C equals heat energy divided by mass times the change in temperature, which can then be changed into the energy equals mass times the specific heat times the change in temperature, or also known as the famous Q equals MCAT formula. Specific heat is an important factor in all energy and heat calculations. Specific heat allows us to determine how each individual sample will react to the heat or energy applied to the sample. Therefore, it is possible to determine how much energy is needed to heat an object to a certain temperature, or it allows us to predict what will happen by adding two objects of different temperatures together. More so, specific heat allows us to distinguish between the different phases within an element, making one's calculations even more accurate. For example, water, in liquid form, has a specific heat of 4,186 joules degrees Celsius per kilogram. But in the solid form of ice, it is just 2,050 joules degrees Celsius per kilogram. For my two example problems, I chose them from the chapter 20.2, specific heat and calorimetry. I chose number 5 for my first one. It states, what mass of water at 25 degrees Celsius must be allowed to come to thermal equilibrium with 1.85 kilograms cubed of aluminum initially at 150 degrees Celsius in order to lower the temperature of the aluminum to 65 degrees Celsius. Assume any water turned to steam subsequently condenses. In order to find the equation, we can first use the variables given. We're looking for the mass of the water. We know the temperature of the water is 25 degrees Celsius, and we know the mass of aluminum is 1.85 kilograms, and the temperature of aluminum is at 150 degrees Celsius. Given these variables, we can set up two of the MCAT formulas equal to each other. The mass of the water times the specific heat of the water times the change in temperature of the water is equal to the mass of aluminum times the specific heat of the aluminum times the change in temperature of the aluminum. By plugging in the variables, it is then found that the mass of the water needed is 845 kilograms. For my second problem, I chose problem number 6. The temperature of a silver bar rises by 10 degrees Celsius when it absorbs 1.23 kilojoules of energy by heat. The mass of the bar is 525 grams. Determine the specific heat of silver from this data.
Hard play, hard work, hard.
Given the change in temperature is equal to 10 degrees Celsius, we can then find that the energy needed.
Yo, these cookies are fresh out the oven. They're hot!
Given the change in temperature is equal to 10 degrees Celsius, and that the energy applied is equal to 123 kilojoules, mass is equal to 525 grams. However, what is the specific heat? Using the equation that the specific heat is equal to the energy applied divided by mass times the change in temperature, we then can plug in the variables and to find that specific heat is equal to 234.3. However, it is important to know that you must convert the kilojoules to joules and the mass from grams to kilograms.
Speaking of physics, do you know where my Apple TV is, Zachary?
In conclusion, it's important to remember how important specific heat is to energy and heat calculations. Specific heat determines how one element reacts and how different things react according to what it's made of. For example, specific heat tells us the difference between Miles' body heat,
which is so hot!
and how much energy it takes to heat Grady's body.
So cold.
Thank you, and have a good day.
I'm here to call